Okay, here we go. Now we're recording. Okay, so it says match the normal curve with the parameters. Okay, so remember, the number here in the middle is going to be our mean. Okay, so this here is going to be our mean every single time. Okay, and so if I look at, say, the first one here, the first one labeled D says my mean is 3.5. So what I'm going to do is I'm going to look at my pictures A, B, and C. Here's my A, my B, and my C, and I'm going to look for the one that has a mean of 3.5. So actually, if you notice here, and my line kind of came down a little crooked, so I'm going to try to fix that as best I can. But here I'm at 3.5, and right here I'm at 3.5. So I have two of them that have means of 3.5. So then the next thing I need to do is I need to look at the spread, okay? So the standard deviation is going to give me what we call the spread. So when I look at graphs A and B, both of them have a mean of 3.5, just like D and F do. So now the difference is going to be which one has a bigger spread. So if I look at this spread here, this spread is 1.5, and this spread is only 0.7. It's not even 1. So the graph that's more spread out, it's wider, is going to have the bigger spread. So that's telling me that A is going to get matched over here because this has a bigger spread, and B is going to get matched with this one because it has a more narrow spread. So I'm not necessarily concerned about the height. I'm concerned about more like the width, okay? And then, so then by process of elimination, that's telling me that E here should probably be this one. And if I double check, look, here's my median. Right in the middle is 1.5. And yep, that looks pretty good. And again, my spread, the graph is not very wide, right? The graph is not too wide from there to there. So that's why that one is going to be matched with C. Okay. Now let me jump over to number 2. And number 2 says, answer each question below pertaining to the following normal distributions. And it says, which normal curve has a greater mean? So remember, the mean is going to be the middle of the graph, okay? So when I look at this one here, right, when I kind of come down and notice those two are about the same, if this is 40 and that's 50, this here is probably about 45. And if I look at the middle here is 60. So I'm looking for the middle, right? Which one has the greater mean? Choice B, right? The graph of B has the greater mean. Now, part B here says, which one has the greatest standard deviation? So this means which is the graph that is the widest. Okay, so the graph that's the most wide or the widest would be choice C, because if you can see here, choice C is much wider than the other ones. Again, I'm not so concerned about the height. I'm more concerned about the width of the graph. And then part C says which two curves have the same mean. So the ones that have the same mean, the ones that have the same middle, are going to be A and C. And then part D says, what is the mean of the curve of B? So here was B, and we said our middle was 60, okay? All right. And so now if I kind of scroll down here and I take a look at part 3, and it says, what's the mean weight and the standard deviation for all newborns in the US in a recent year? So remember, the first thing I'm going to do, I'm going to look for my mean. So the mean is going to be the number that's right in the middle, right? So the one that's right in the middle, that number looks like it's going to be about 3,300. Okay. Now the next thing is I'm going to find my standard deviation. So the way I find my standard deviation is I'm going to look right here at this point and right here at this point. And what I'm going to do is I'm going to just kind of just drop down a little bit. And what I'm looking for is, what is the distance between these numbers here, or the distance between this number and this number, or this number and this number. Now, I'm obviously going to do some kind of a guess here, right? So if I zoom in a little bit, just so I can get my picture to look a bit, so I can get a better look at it. If I know that this number here is, say, 2100 and this number here is 2700, I'm going to take a guess, right? I might say this number here might be something like 2500, right? Now, obviously, I'm taking a guess, so I'm not going to be 100% accurate, but I'm going to take a guess, and hopefully that my guess is relatively close, right? Okay, so now if this number here is 2500 and this number here is 3300, and I'm looking for the distance, I'm just going to subtract those two numbers. So I'm going to say, what's 3300 minus 2500, and I'm going to come up with 800. So that would be my guess, right? That would be my guess there. Or vice versa. I might say, if I look at this number, if this is 39 and that's 4,500, I might say, you know what, this number here looks like it's going to be about 4,100, right? 4,100. And so I would take the distance between those. So I would say, what's 4,100 minus 3,300? And that's still going to be 800 there, right? So I'm looking for, when I'm doing this problem here, I'm taking a guess, but I'm trying to take a good guess, right? So like I wouldn't say, if I'm looking at the number, I wouldn't say it's like, oh, it's 7,000 or something like that. Or if I'm looking at this number here, I wouldn't say, oh, it's like 900, right? I know I'm going to guess somewhere between 21 and 27, and closer to 27 than to 21. Okay, and so number 4 is asking me to do exactly the same thing. It says, the scale test scores for the New York State Grade English tests are normally distributed. Estimate the mean test score and the standard deviation. Okay, so I'm going to do the same thing we did before. Here's my high point, and I'm just going to kind of come straight down. Okay, and there's going to be my mean. So if you notice, if this is 640 and this is 660, this number here would be 650, and because I'm between those two, I'm going to just estimate that to be 655, okay? All right, then I'm going to look for my inflection point. So the point here, and the point here, and I'm going to come down here, or I'm going to come down right here, and I'm going to say, okay, what do I think my number is now? Can I come up with a good answer? So if this is 620 and that's 640, I know that's got to be 630. Okay. So now, if this number here is 655 and this number here is 630, I'm going to take 655 minus 630, and I'm going to come up with my standard deviation being 25, right? Or I can do it vice versa. I can do it from the other way too. I could say, hey, well, look, if this is 680 and that's 655, that's still going to give me 25. So give me one quick second. Let me come back here for un momento. And so, Erica, as I'm going through these, is this making a little bit of sense as I'm doing this? Yeah, we're good so far? Okay, I'm just checking with you. If you got any questions, please let me know. Remember, I'm here to help you guys, so I'm happy to answer any questions you have. But I can kind of give you an idea, or at least an approach on how I'm trying to do this. We're good so far? Thumbs up? Okay, excellent, great. So let me keep going here. Let me scroll down a little bit further. And we're going to do exactly the same thing in this next problem, okay? So we're going to look for the same type of approach. We're going to say, what's the mean on the normal curve? And we're going to try to find our standard deviation. So I did this same section with my other stats class last week, and you know, they were saying, well, sir, you know, when I find my standard deviation, what happens if I'm off a little bit? And I said, that's okay if you're off a little bit. The idea is it's going to be an estimate, right? So remember what an estimate is. It's a guess, but it's a good guess. So if you're off by 1 or 2 or 3 or 4, it's probably not going to be a big deal. But if you're off like by 100, then you're going to have some issues, right? So first thing we're going to do, we're going to find our average. So the average just says go straight down, and we are at 52. Okay. Now I'm going to find my standard deviation. And so I can either use this value or I can use that value. It doesn't matter which one I use, I'm still going to get the same thing. So I'm going to do these here. So 52 minus 40 is going to give me 12. And so there's my standard deviation, that little O with the little hat's called sigma. That's going to give me my standard deviation. Okay, so now let's take a look here. And it says standard normal distribution. So the reality is that there's infinitely many normal distributions to represent infinitely many situations with infinitely many means and standard deviations. The normal distribution with a mean of 0 and a standard deviation is 1 is what we call the standard normal distribution. So in the standard normal distribution, the mean, mu, is going to be equal to 0, and sigma is going to be equal to 1. And the area under the curve is still 1. That's still going to be the case. So let's see. Excuse me. Here it says, recall that a z-score for a random variable x is a measure of the position that indicates the number of standard deviations the value lies from the mean. So this is how we were computing our z-score. We would take the value minus the mean and divide it by the standard deviation. So it says, when each data value of a normally distributed random variable x is transferred into a z-score, then what we're getting is the standard normal distribution. So I'm going to kind of scroll over here, and I'm going to kind of walk you through the process and how we're going to do this here. So this is my standard normal curve right here. The idea is just like the other one, the graph goes on and on and on and on and on forever, okay? And I get really close this way, but I don't touch, and I get really close that way, but I don't touch. The area on this side of the graph is 0.5, and the entire area is going to be 1, okay? Let's see. And so what we're going to do here is I'm going to show you how we're going to use something called the standard normal table to do these problems here. So these are in this. I'm going to pull up a file, and I'm going to show you actually where I'm going to get it. So I'm going to stop sharing this screen right here, and I'm going to share a different one with you. And let's see. Okay, so we're here. So the notes that I'm working on right now are from chapter 5. And so all I did is I clicked this here, and I was getting my notes from chapter 5, right? So the other thing I have here is this file called statistical tables. So I'm going to do the same thing. I'm going to click on this, and I'm going to click on download original file, right? So I already have that file, so I'm going to open it up right now. So give me one quick second so that I can pull it up. Here we go. Okay. And let me come back to our notes. No, here we go, our notes. And let's see. Okay, so we can see this now. So it says, we're going to find the cumulative area that corresponds to a z-score of negative 1.25. Okay, so the way I'm going to do this here is I'm going to zoom in on my picture a little bit. I'm looking to figure out where can I find negative 1.25. Well, here's negative 1 and here's negative 2. So negative 1.25 is going to be right about there. And in essence, what I'm doing is I'm trying to find the area to the left of my curve, okay? And so there's two ways that I can do this. And the first way is by using a table, okay? The one thing I want to make sure that we understand is when I use the table always is going to tell me the area to the left. It's always going to tell me the area to the left, okay? So when the problem says find a cumulative area that corresponds to a z-score of negative 1.25, they're asking me, can you find the area to the left of the curve at negative 1.25? And so the way I'm going to do this is I'm going to stop sharing this screen, and I'm going to pull up the table that I was telling you about that I pulled up here. And so let me see. Yes, you can see that now. So I want to find negative 1.25. So if you notice here, I have negative 3.4, negative 3.3. I'm going to come all the way down right about here. Here's my negative 1.2. But I don't just want negative 1.2. I want negative 1.25. So what I'm going to do is, here's my negative 1.2. If you look right here, that's a 0.05. What I'm looking for is, where do those two meet up? Because in essence, what I'm doing here is I'm taking negative 1.2 plus 0.05, which leaves me with a negative 1.25. So the value that I'm coming up with here is 0.1056. So all I'm going to do is I'm going to stop sharing this part. I'm going to come back to my notes. And right here, I'm going to say the answer for this part here was 0.1056. And so I can do this using my table, and it's going to work every single time. Now, instead of using my table, I can do this using my calculator as well. And I'm going to show you how we can do this using the calculator. So on my calculator, there's going to be a couple of steps. The first thing we're going to do, we're going to hit the second button, and then we're going to hit the button that says bars. Second thing we're going to do, we're going to look for something called the normal CDF, okay? And when it gives me the normal CDF, it's going to give me a lower bound, and let me write it like this. My lower and my upper number, okay? So I'm going to walk you through this process, and I'm actually going to write it out here so you can see what it is I'm going to write. So normal CDF, and my lower number. I want you to think about this picture for a minute. Remember, I'm looking for the graph for the area to the left of that number. Here we go. So I'm trying to find all this area all the way over here to the left. Since I'm going all the way to the left, and I basically go forever, when we go to the left forever, that's like a negative infinity. If I were to move to the right forever, that would be like a positive infinity. Because infinity is not actually a number that I can plug in, what I'm going to do is I'm going to write in a number. And the number that I'm going to write in is going to be like a negative, and I'm going to put a whole bunch of nines. By a whole bunch, I usually just mean about 4. You can put 3, you can put 5, but I wouldn't put less than 3. And then where am I going to stop? Remember, the number where we stopped at was a negative 1.25. So that's going to be my upper number, okay? And I'm going to show you how I'm going to do this on the calculator. So I'm going to get my calculator going here. And let me stop sharing this. And let me come back to my calculator, and I'll turn it on. And so, let's see, here we go. Okay. So I'm turning it on here. Here we go. And I'm going to hit clear. Okay, so we said we're going to hit second, and then we're going to hit the bars button. And I'm going to go down to number 2, which says normal CDF. Okay, and I'm going to hit enter. And whether I'm using a calculator or whether I'm using my calculator app, it's going to be the same thing. The process is going to be exactly the same. So you said, remember, we're going to put 2 numbers. The first one's going to be my lower number, so a negative 9999, comma, and then my upper number was a negative 1.25. I'm going to close that off. And I'm going to hit enter. And I want you to notice that the number that I'm coming up with here, 0.1056. And that's the same number that I came up with when I used my table, right? So when I'm doing these problems here, I'm really going to have a couple of options. I can decide, do I want to use my table or do I want to use the calculator? And it's really going to be up to me to decide whichever one I want to use. So anyway, I'm gonna get the same answer regardless, right? So let me stop sharing this part here, and then let me come back to my notes, and we'll continue on, and I'm going to keep doing this here. And let's see. So number 7 says, let's find the cumulative area that corresponds to a z-score of 2.15. Okay, so here's 2.15. Remember, it's going to be all the way, it's going to be pretty far to the right, and I'm looking for the area all the way to the left of this, right? So I want you to think about this again for a second, right? When I use my calculator, if I'm going to use my calculator, right, I'm going to go normal CDF. And the way I'm going to figure out what are my lower numbers and what are my right or my upper numbers is, remember, on my number line, all the way to the left, I have a negative infinity, and all the way to the right, I have a positive infinity, right? So if I'm all the way to the left over here, and this is where I'm starting, this is my lower number. So that's going to be my negative 9999. Where am I stopping at? Well, we're stopping at 2.15, right? That's where I'm stopping at. So I'm going to do this, and I'm going to show you again. I'm going to show you 2 ways of doing it. I'm going to show you how to do it in the calculator, and I'm going to show you doing it using the table. So let me stop sharing this. Let me come back to my calculator, and we'll do the same thing. So here we go. So let me just clear this out again. And again, I'm going to go second and then bars. I'm going to go down to my normal CDF. And I'm going to type in negative 9999. And then I always have to hit a comma. And then we were doing a positive 2.15. And close off my parentheses. And if I look at my answer, by the way, when you're doing these problems, my lab is always going to ask you to go to 4 decimal places. So I'm just going to write this down on a piece of paper real quick. So I'm coming up with 0.9842. Okay, so I'm coming up with 0.9842. And now I'm going to show you, using the table, do I still get 0.9842? So if I stop sharing this part here, and I come back to my table, here we go. And the number we wanted was a 2.15. So if you notice, these numbers here are all negative. I need to get to the positive part. Okay, so positive, I'm looking for a 2.15. So if you notice, right here is 2.1, and over here is a 0.05. So if I notice where those 2 points meet, right here at 0.9842, and that was the same answer that I came up with on my calculator, right? I got the same exact thing. So if I want to use my calculator, I can do it. If I want to use my table, I can do it. So let me come back to the next problem and see if we can do the same thing that we did right now. And here we go. Okay, so we came up with the answer of 0.9842. That was the answer we got, whether we use the calculator or the other one, right? Now, so now doing this on for number 8, it says, find the area under the standard normal curve to the right of z equals negative 1.05. So negative 1.05 is just barely to the left of negative 1. But the problem is telling me we're looking for the area to the right of this number. So I'm not looking for the area here. I'm actually looking for the area all the way over here. So remember we said this was a negative infinity and over here was a positive infinity. So if I'm going to do this using my calculator, what I'm going to do is I'm going to use normal CDF, right? Now remember, we're going to have 2 numbers. The first one is going to be our lower number. I actually started my graph at negative 1.05. And because we go on to the right and all the way forever, remember, I can't use infinity. So instead of using a negative 9999, I'm going to go with a positive 9999. Okay? So I'm going to show you how I'm going to do this on my calculator. This is exactly what I'm going to type in. And so I'm going to go back to my calculator right here. And let's see. So I'm going to go second bars. Scroll down to normal CDF, and the number we had was a negative 1.05, comma 9999. And I'm going to close that off. I'm going to hit enter. And the answer that I'm coming up with, and I'm going to write this down, is a 0.8531. Okay, so 0.8531. So I'm going to stop sharing this. I'm going to come back to my notes. Here we go. And the answer that we came up with was a 0.8531, right? Now, what happens if I want to use my table? Okay, so remember, anytime I'm using my table always tells me the area to the left of that number, right? So when I use my table, the table is actually going to give me this red area when I'm really interested in the green area. But I'm going to show you how I can do that anyway. It's still going to come out. So let me go to my table, and remember the number that I'm looking at here is a negative 1.05. That's the number that I want to use on my table. So I'm going to stop sharing this part here. I'm going to come back to my table. Go. And the number that we said that we were interested in was a negative 1.05. Okay, so let me see, where's 5? Here's my 5. Here we go. So here's negative 1.0. Here's 0.05. Those two meet up right here. So the number that I'm going to write down is going to be 0.1469. Okay, 0.1469. So I'm going to stop sharing this. And I'm going to come back to my notes one more time. Okay. And when I was using my table, the answer that I came up with was 0.1469, right? That was the answer that I came up with. But that was actually giving me the area right here. So when I want to find this green area here, the area under the entire curve, so the total area is equal to 1. So when I want to find this piece here, what I'm going to do is I'm going to say, let me take 1 minus 0.1469. And if I take my calculator and I take 1 minus 0.1469, we come up with 0.8531. So I can still use my table. I can still use my table if I want to. I have to do an extra step, but I can still do that, okay? So when I did this with my other class last Thursday, I told them, you know, it's really going to be up to you to decide, do you like the table better? Do you like the calculator better? It doesn't really matter to me. Whichever one works for you is the one you want to, is the way you want to do it. You just want to find one that works for you, okay? So one of them has to work, or you got to make one of them work. It's just which one seems better for you. Okay, so let me scroll down a little bit more. And I'm going to start using my calculator a little bit more because I think the calculator is going to go a little quicker. But I have had people before who prefer the table, but I'm going to use the calculator just a little bit more. So let's see. We want to find the area under the curve to the right of 2.50. Okay, so here's 2.5. And we're looking for the area to the right. So I'm looking for this area right here. My guess is this number is going to be pretty small because remember the area under the whole thing is 1 and I'm only finding the area this way. Remember, if I keep going all the way to the right, this is infinity. This is a negative infinity, right? So if I use my calculator, I'm going to go normal CDF and I'm starting off at 2.50, so 2.50, and I'm going to end at 9999. Okay, so let me stop sharing this and let me come back to my calculator. Here we go. Oh, that's not that. This one here. Okay, and I'm just going to turn it back on. And so I'm going to go second right here, second, and then bars right there. Normal CDF, enter, so 2.50, comma, and then 1, 2, 3, 4. And again, my answer is going to be probably a pretty small number. And if you notice, 0.0062. So pretty small number, 0.0062. So I will stop sharing this. I will come back to my notes. And we came up with a 0.00062. Okay. All right. Let's see. Number 10. Number 10 says, let's find the area under the standard normal curve between negative 1.25 and a 0.65. Okay, so remember, negative 1.25 is going to be somewhere right about here. And a 0.65 will be a little bit more than halfway, 0.65. And I'm looking for the area between these two pieces right here, okay? So the reason why I always do this part showing you all the picture is because when I show you the picture, I can figure out when I'm using my normal CDF, what are my lower numbers and what are my upper numbers? So looking at this right here, it tells me, hey, you know what? My lower number is a negative 1.25, and my upper number is a 0.65. And so I'm just going to do this on my calculator. I'm just going to do it on the app real quick here. So let me get the calculator going. And get out of here. Let me see what too many things on my iPad open, so you're closing this stuff up. All right, so I'm going to go second bars, normal CDF, and I said negative 1.25, comma, let's see, 0.65. And when I hit enter, I'm coming up with a 0.6365. And we're done, right? And so I'm going to skip over 11 because 11 is pretty much exactly like the one we just did right now. Excuse me. That's going to be my lower number. That's going to be my upper number. But hopefully it makes a little bit more sense. And I do want us to go through number 12, okay? Because I think number 12 is going to be important to do. And we can probably even do a little bit of 5.2 if we have some time. But this last problem here, number 12, this is pretty much what 5.2 looks like. And it says, in the next section, we're going to learn how the area under the curve for a given value of z is actually the probability that z is less than that z-score. And it says, for example, since the area to the left of z equals negative 0.99 is 0.1611, then that means that the probability that z is smaller than 0.99 is 0.1611. And it says transforming non-standard normal distributions to z-scores will help determine the probabilities of certain events. So example, or problem number 12 says, if we go back to problem number 4, where we had the test scores for the New York State grade English test, what's the probability that a student chosen at random scored less than a 640 on the test? Okay, so a couple of things we're going to do here. First thing we're going to do, we're going to find the mean. So when we found the mean earlier, oops, pen freezes, here we go. When we found the mean earlier, I want to say we said our mean was 6.5. And then our standard deviation, the distance from here to here, this number here was 630. So my standard deviation was 655 minus 630, came out to 25. Okay, so I have my mean and I have my standard deviation. So what we're going to do here is we're looking for, when I read the question right here, what's the probability that a student chosen at random scores less than a 640 on a test? The way I would write that out would be, what's the probability that x is smaller than 640? So what I really want to do is I want to convert this part here to a z-score. So the way we convert x values to z-scores is we use this formula. Z equals x minus mu divided by sigma. So the x number in this case is going to be my 640. Okay. My standard, my mean, my average was a 655, and my standard deviation was the number 25. Okay. So one thing I'm going to emphasize is when you're doing this part on the calculator, put this piece here in parentheses. Okay. It's always best if we put in parentheses. So let me share with you my calculator so you can see what it is I'm going to do here. And get my calculator going for you. And okay, so calculator's on. Let me just clear the screen. So the first thing I said, I was going to put parentheses, and I was going to type in 640 minus 655, close my parentheses, and then I'm dividing everything by 25. So again, I really want to make sure I put those parentheses, otherwise it won't do the calculation correctly. Okay, so I was going to put my parentheses in there. Then I'm going to go ahead and type in enter. And if you notice, the answer I'm coming up with is a negative 0.6. Okay, so I'm going to come back to my notes, and I'm going to show you what that means. What happens when we come up with a negative 0.6? So here we go. So we came up with a negative 0.6, okay? So what this means now is before we wrote down what was the probability that x was less than 640? What we're going to do now, because we've converted that x value to a z-score, is we're going to say, what's the probability that z is less than a negative 0.6? Okay? So if I look at my picture right here, okay, where would I find negative 0.6? Negative 0.6 would be right about here, a little closer to 1 than it is to 0. And because my arrow is pointing to the left, that's just telling me, hey, can I find the area to the left of that curve or to the left of that value? And yes, I can, because that's what we did in the few problems we did a little while ago, right? So remember when we did this here, we said like, oh, look, this is negative infinity and this is positive infinity. So if I wanted to use my calculator, I would go normal CDF. And I would say, where am I starting off at? Oh man, I'm starting off all the way over here. So I'm going to use that negative 9999. Where do I end up with? Remember, that was a negative 0.6. So I have to stop at a negative 0.6. And so when I go to my calculator, and I'll do that part again, so I'm going to stop sharing this, and I'm going to come back to my calculator. And let's see, here we go. Let me clear this out for you. I'm going to go second and then bars, normal CDF, hit enter, negative 9999, comma, and then a negative 0.6, and hit enter again. And so the answer that I'm coming up with here, it looks like it's 0.2743 if I go to 4 decimal places. For the most part, when you're doing these problems here, you're always going to go to 4 decimal places. And since the number to the right of that 2 is a 5, that 2 is going to bump up. So my answer should be 0.2743. And stop this part right here. Come back to the notes. Here we go. And we came up with 0.2743. And so, in essence, that's what we were doing for these problems here, okay? So, I think this was the last problem out of 5.1. And so what I want to do is, because we do have just a couple of minutes, I'm going to show you how to I want to at least do the first problem out of 5.2. And what you guys have for work this week is 5.2, 5.3, and 5.4. 5.1, that section that I just covered right now, that's one that's due by tomorrow night. I gave you all that extension because my lab software was kind of lagging a little bit, so I checked and it's working again. But I wanted to at least do a little bit of 5.2. And the one thing I want to emphasize about these problems, everything in 5.2 is just like that last problem we did. Okay, so what we're doing is we're going to be converting our problems to like z-scores and then using that normal CDF, or we could use the table if you want to use the table. So So the first problem here says the average speed of vehicles traveling on a stretch of highway is 67 miles an hour with a standard deviation of 3.5. So before I do anything else, I'm going to write down a couple of things. It said the average speed. That's my mu. So my mu is 67. And then it tells me my standard deviation is 3.5. So my sigma is going to be 3.5. And now when I keep reading, it says a vehicle is selected at random. What's the probability that it is violating the speed limit of 70 miles an hour? Okay, so we're going to write it like this. What's the probability that X, when we say it's violating the speed of 70 miles an hour, that means that we're going more than 70. So that means that X is going to be bigger than 70. Okay, because we're violating that speed limit, that means we're going more than that. Okay, so now the first thing we're going to do is we're going to convert this to a z-score. So I'm going to use this formula right here, okay? And I'm going to see if I gave that, did I give you all that formula here? I didn't, but it was at the end of the other one. So I'm writing it down here for you now. So we're going to take x minus mu over sigma. So my x value in this case is going to be this number. So I'm going to write 70 minus 67 over 3.5. Remember, I'm going to do this part in parentheses. And I'm just going to do this here on my calculator so I don't have to keep kind of going back and forth. So give me one quick second. So I'm going to go 70 minus 67 in parentheses divided by 3.5. And for these here, I'm coming up with like 0.8571. I'm coming up with a whole bunch of numbers. For the z value, I'm always going to go with 2 decimal places. So I'm going to write 0.86. Okay, that's another I'm going to put. So what this means is, remember, we were saying what's the probability that x is bigger than 70? Because we converted that x value to a z-score, what we're now saying is what's the probability that z, I'm still going to keep the symbol, is greater than 0.86. Okay. Now, I'm going to draw a picture so that we can get an idea of what does that mean. So here's my normal curve, right? Okay. Here's 0, here's 1, here's 2, here's 3, right? -1, -2, -3. I'm looking for the number 0.86. Well, 0.86 is going to be close to 1, but not quite there yet. And because I'm looking for bigger than that, that means I'm going to be shading all the way to the right. So this number right here is a 0.86. So all that means is that now when I use my calculator and I type in my normal CDF, my lower number is going to be a 0.86. And because I'm going to the right forever and ever and ever and ever, my upper value is going to be that 9999, right? And so let me do this part one more time and come back to my calculator so that we can see what it is I'm doing. And let's see, here we go. So I'm going to go second and then bars in normal CDF. And we had a 0.86 and then a comma with a whole bunch of 9s. And my answer is 0.1949. So that's what I'm going to write down, 0.1949. So let me stop sharing that and come back to my notes one last time. And we came up with 0.1949. And we're done. Okay. So number 2 is going to be the same type of problem. Okay, you're going to go ahead and so you're going to have in part 2 because there is an A, B, and C. And I'll tell you what, I'm going to at least set up. I'm going to set up the problem for you on problem 2. And the only part that I won't do this piece here for you because I think you probably handle that part now. So if I look at number 2 here, and it says monthly utility bills are normally distributed with a mean of 100. So there's my mean. And a standard deviation of 12. So my sigma is 12. And part A says, find the probability that the utility bill is less than 70. So what this is saying, what's the probability that X is smaller than 70? We're going to first convert that to a z-score, okay? So we're going to take 70 minus 100 divided by 12, okay? So let me do that again. 70 minus 100 divided by 12. And I'm coming up with negative 2.5. Okay. So what that's telling me is it's asking me now, what's the probability that Z is less than negative 2.5, right? So again, I'm not going to do the calculator part for you, but if I were to draw my picture, here's 0, here's 1, here's 2, here's 3, here's minus 1, here's minus 2, here's minus 3. 2.5 negative is going to be right here. And I'm looking for the area to the left. And so that's when I would use my normal CDF, and I would put my lower number and my upper number, right? And the reason why I draw the picture is because, remember, I'm looking for the area of the red part. And if I draw my picture, then it's easy for me to figure out what's my lower number, what's my upper number, okay? So then let me set up part B for you. So notice what it says here. Find the probability that the utility bill is between those two numbers, okay? So all that means is that X is going to be between 90 and 120. So what I'm going to do here is I'm going to find two Z values, okay? So I'm going to call one of them Z1, and I'm going to call the other one Z2. So for Z1, I'm going to use 90. So I'm going to go, what's 90 minus 100 divided by 12? So let me do that on my calculator. 90 minus 100 divided by 12. And okay, so I'm coming up with a negative 0.83. And then my Z2 value is going to be this number. So 120 minus 100 over 12. So 120 minus 100 divided by 12. And that's giving me 1.67. Okay. So now, what this is telling me, if this is what I was originally looking for, but we've converted them to Z values, what we're going to say now is, what's the probability that Z is between those two numbers? So when I draw my curve, oops, and there's my 0 and my 1, oops, and my 2 and my 3, and my minus 1 and minus 2 and minus 3. The numbers that I'm interested in, negative 0.83 right here, and 1.67 right here, and I'm looking for the area in the middle, so I know my lower number and my upper number. So when I use my normal CDF, now I know what my lower number and my upper number are. Okay. And I got one more just to set up for you, and then I'll let you kind of, work your way through the others. So part C says, find the probability that utility bill is more than 140. Okay. So here we're saying, what's the probability that X is more than 140? Okay, so if I'm trying to figure out this part here, remember what the first thing I'm going to do? I'm going to find my Z value. So X minus mu over sigma. Oops, a lot of parentheses there. So I'm going to go 140 minus 100 over 12. So 140 minus 100 over 12. And I'm coming up with 3.33. Okay. So now what I'm going to do is I'm going to say, look, if we converted that x value to a z-score, what we're saying now is what's the probability that z is greater than 3.33? So if I draw my picture, right? Here's my 0, my 1, my 2, my 3, -1, -2, -3. Oops. And I'm looking for 3.33. So remember what 3.33 is. 3.33 is going to be over here. And I'm looking for that little bit of area right there, right? So again, now I know where my lower number is, and because I go all the way to the right, I know where my upper number is. Okay. All right, so let me stop doing this part here. Oh, you know what? Let me put it back up because I think we were copying something. I want to make sure that you got it. So Erica, I hope that part there made some sense. So just to give you a heads up, for this week, you guys should be doing 5.2, 5.3, and 5.4. And then next week, we're going to take a test on Thursday. So I shared with you all that information there. So all the assignments, let me stop sharing this part because I just want to make sure that you're good with what it is we're doing next week. Okay, so the 5.2, 5.3, and 5.4 are basically due by let's see, by midnight on Thursday, as well as the review. That's when the review is. And then the test is going to be next Thursday as well. And I'm going to have 2 sessions, one at 10 in the morning and one at 6:30 in the evening on Thursday. So you can just click right here and it'll take you to the sign-up sheet so you can write your name on whichever one you want. And next Wednesday, here we go, at 6:30, I'm going to be doing a review session for the exam, so I can go over any questions out of the review. I can answer any questions you guys have. But you basically got, about a week in a day or so to do 5.2, 3, 4, and the review. So in the meantime, let me stop sharing this part here. If you have any other questions on anything, please let me know. Send me a message on Reminder Pano, and I'm more than happy to answer them.